Good afternoon, pilot teachers, and good afternoon, students. Thank you. Sit down. Okay, today we are going to look at least 2 examples of local winds before you are set off to do your assignment, of which your assignment is going to be based on looking at local winds. We have already covered work on planetary prevailing winds, that is winds on a large scale and winds that are consistent or that blow consistently right throughout the year. And today we are going to look at least 2 examples of local winds. And when we look at the examples, we are going to be looking at winds which are confined to certain areas around the world or on a smaller scale. But before we go ahead to looking at examples of local winds, I'd like us to recap on what we have covered already on looking at air circulation mainly in the northern hemisphere and the southern hemisphere. And before we came to looking at air circulation, the basic part of it, it is important for us to understand our diagram again. That diagram containing the pressure belts, the high and the low, and as well as that, the diagram containing the movement of air in the different hemisphere. Also, the deflection of the major planetary winds to the right in the northern hemisphere and to the left in the southern hemisphere. So if we look at that diagram quickly, the surface winds blowing from the 30 high to the equator. Then we have those that are blowing from the 30 degrees high to the 60 degrees. And we have the winds blowing from the polar regions, the high polar to the 60 degrees north and south. This diagram then represents on the surface the major planetary prevailing winds and the pressure belts. Meanwhile, we also did an activity or exercise in our last lesson, and that activity or exercise had to do with winds that are blowing not on the surface but rather further up in our troposphere. One of the examples we looked at was the jet streams, of which the jet stream makes up the higher atmospheric winds, and the importance of the jet stream has been discovered recently, whereby in navigation, in terms of pilots flying, they could actually use that wind to get them a little bit more quicker from one place to another. Okay, the jet streams itself, if we look at this diagram here, plus the other winds which are higher up in our troposphere, not the surface winds, they also create what we call cells. And some of the examples of cells which are created as a result of those winds which blow higher up in the troposphere are such as the polar front or the polar front jet found within the polar regions where the polar easterlies are located. Then we have the subtropical jet, which makes up what we call the Hadley cell or the Hadley cell, found within the equator and the 30 degrees north and south, but in higher altitude. And we also have in the southern hemisphere the Hadley cells, which are the subtropical jet, the polar front jet, and also the polar front cells. The information represented outside of the diagram here basically shows us some of the winds which are blowing, but winds that are blowing at a higher altitude. The major surface winds are what we have already looked at. On the surface, the trade winds, the westerlies, and the polars. Okay, we move on. We also looked at generally the circulation of the air into the lows and out of the highs in the different hemisphere, the northern hemisphere and the southern hemisphere. Also, I mentioned that whenever a low pressure system is actually formed or developed, air tends to flow into it. Whenever a high pressure system develops, air tends to flow out of it. However, we also have learned that the rotation of the earth has an important effect on all air movements. It causes the air to be deflected to the right in the northern hemisphere and to the left in the southern hemisphere. Thus, the air moving into lows and out of highs tend to spiral in and spiral out. In the southern hemisphere, we have already learned that air will spiral into the lows in a clockwise direction and out of the high in an anti-clockwise direction. Let's look at the diagram to help us understand that. In the southern hemisphere, into the low, air will spiral in a clockwise direction into the low. Out of the high, it will spiral in an counterclockwise or anti-clockwise direction. In the northern hemisphere, air will spiral into the low anti-clockwise and spiral out of the high in a clockwise direction. The diagram to help us understand that. In the northern hemisphere, into the low anti-clockwise or counterclockwise. Out of the high in the northern hemisphere, air will spiral clockwise. Okay, having looked at that information, we are now ready to look at the information on local winds. If you can make reference to the handout or the worksheet that has been distributed, we will look at the introduction to the work on local winds, and then I will explain an example of a local wind which is on land and sea breeze, of which most of you should be very familiar with. Okay, looking at the information from the handout or the worksheet now, the introduction part of it under the heading on local winds. You found that information? Okay, it tells us there that when we are making reference to local winds, terrain and other conditions in certain localities generate what we call the local winds or the minor terrestrial winds. These winds, which are rather independent from the large-scale pressure system or systems that cause the occurrence of the global wind circulation system, are still important in specific areas where they occur. The extremes in temperature and moisture that they can cause affect the comfort, growth, and survival of plants and animals. Local winds also influence the movement of air pollutants from factories. So when we come to studying now some examples of local winds, we'll have to also understand that these local winds, they are not to do with the major planetary pressure belts. The major planetary pressure belts, they have an influence on the major planetary prevailing winds. Local winds, there might be some other local factors that could have an influence on why those winds are blowing. Okay, we'll start off now with the first example of a local wind, which is known as the land and sea breeze. For us to understand land and sea breezes, it is also important for us to revise and recap on what we have covered on the heating of the land and the heating of the water or the sea. We already know that land will heat up quickly, but it will also lose heat quickly. Meanwhile, water heats up slowly and also loses heat slowly. Knowing that basic fact, we come now to looking at information on land and sea breezes. By day, the land heats up quickly. We know that already from the basic fact that I have just mentioned. And because the land heats up quickly, what would happen then is over the land, the area is warmer or hotter. Meanwhile, the sea heats up slower or slowly. Therefore, over the sea, it will be cooler. Because the land is hotter or warmer, the air will actually rise where the warm area is. So upon rising, what will be created over land then will be a low pressure area, because low pressure is associated with rising air, warm air rising. Okay, that air that has actually risen then will create a low pressure over the land. This is by day. The air rises, finally it will cool and descend. Upon descending, it will create an area of high pressure. And from what we have already learned, winds will always blow from high pressure areas to low pressure areas. Therefore, because the winds then will be blowing from the sea towards the land during the day, they are referred to as the sea breeze. Okay, nighttime. By night, the land loses its heat quicker the sea will lose its heat slower. Therefore, it is warmer over the sea. It will be cooler over the land. This is nighttime. Because it is warmer over the sea, the air will actually rise over the sea. Upon rising, it will create an area of low pressure. The air rises, cools, and then sinks over the land. Upon sinking over the land, it will create an area of high pressure. Winds will always blow from high pressure areas to low pressure areas. Therefore, during the night, the winds therefore will be blowing from the land towards the sea, giving rise then to the land breeze. Okay, so for most of you who come from the coastal areas, perhaps by night, when you go to swim in the sea, you will tend to find that the sea is warmer or a little bit hotter compared to perhaps during the day. Okay, and the development of the land and the sea breezes is as a result in the variation in temperatures, and also the variation in temperatures giving rise then to the high pressure and low pressure over the land or the sea, giving rise then to winds blowing from the high pressure areas to the low pressure areas. And this is actually on a smaller scale. Therefore, it is referred to as an example of a local wind. Any questions on that? Any questions? No questions? Okay, I'm going to give you time. And I'm going to give you time then for you to make note of these two diagrams explaining the land and the sea breezes. Okay, when you copy those diagrams down, I don't want you to just copy the information. If you can write a little bit to go with a little bit of explanation to go with the diagrams, then perhaps you will understand what the diagrams are actually showing. Sorry. Okay, that's fine. You also have the worksheet here. That information there should be good enough for you to actually look at and make note of, so that's fine. Okay, most students should have already got their diagrams down. Ensure that you also have some explanation to go with those two diagrams so that you understand what those diagrams are showing. We'll move on. I'd like us to look at the second example of local winds, and this time we're going to look at mountain and valley breeze. You have some information presented on the worksheet which has been distributed, and I'd like you to make reference to the information from the worksheet for your background readings to understand the information on mountain and valley breeze. Okay, so the first example we have already looked at, the land and sea breeze. We'll move on now to looking at the mountain and valley breezes. Note also that when we're looking at mountain and valley breeze, the main reason for why the high pressure or low pressure areas develop within that small scale is mainly to do with the temperature. During the day, the slopes of the mountains get heated up quickly. Upon heating, it will give rise then to a low pressure area being created. And because the slopes of the mountain gets to be heated, a low pressure area develops, then what happens is that air rises where the slope of the mountains are. And as soon as the air rises, it will give rise then to winds blowing from the valley towards the mountain slopes. Therefore, by day, a term that we use to describing that breeze then is called a valley breeze. I'll repeat that. During the day, the slopes of the mountains get to be heated up. If we are looking at what we have covered on aspect, if you were in the northern hemisphere and you have a mountain which is actually situated in such a position or way that the northern part of it is facing the north and the southern part is facing the south. If you were in the northern hemisphere, which slope will get heated up more quickly? The southern slope, correct. In the northern hemisphere, the southern slope then gets heated up quicker. So if we look at an example here, the diagram here may be representing a mountain in the northern hemisphere. This area here becomes the southern slope. It gets heated up quickly. What happens then? Heat rises where the slope is, giving rise to a low pressure area along the slope. Air from a high pressure area will have to move in to the low pressure area. And that high pressure area then will be the valley floor, because the slopes get heated quicker than the floor, the valley floor. So it is hotter along the slope. Air rises because it's warmed, giving rise to a low pressure area. Winds then will blow from the valley floor towards the slope. So during the day, we call the movement of air then the valley breeze. We understand that? Okay, then we look at by night. By night, what now is actually happening is through radiation, that is the losing of heat, the slopes then will lose their heat quicker. And when they lose their heat quicker, it will be cooler or colder along where the slopes are. The valley floor will lose their heat slower, therefore they are warmer. And because they are warmer, the valley floor, the air rises from the valley floor, giving rise then to a low pressure area on the valley floor. Meanwhile, it is cooler along where the slopes are, resulting then in the air moving from the slopes down towards the valley floor. So by night, the term now we use to describing this example of that local wind then will be the mountain breeze. So nighttime, it is the mountain breeze. Daytime, we call it the valley breeze. Any questions on the example now of the mountain and valley breezes? The concept is very similar to what we have looked at on the land and sea breezes. Both of them have to do with temperature differences. During the day, it gets hotter, air rises, giving rise to a low pressure area. Winds from a high pressure area will have to move in to take the place of the rising air. And during the night, it gets cooler at a certain spot, hotter at another spot. Again, where the area is hotter during the night, air rises, giving rise to a low pressure area, and winds or air from a high pressure area will have to move in to take the place of the rising air. Anyone with any queries or questions to ask with regard to the mountain and the valley breeze? Do you all understand now why mountain breeze okay and why valley breeze is okay? Do I need to explain it again to you, or you are clear with the explanation? You are clear with the explanation? Okay, good. I am now going to give you time similar to what we have done on the local, the land and sea breeze, to make note of the diagrams. I'd like you to also make note of the diagrams by day and by night for the mountain and valley breeze, and also write a little bit of explanation to tell us what the diagram is showing. You can make reference to your handout or to the worksheet to help you with your construction of the diagram and also written explanation. This is the diagram, but it's not very clear on the monitor. It's just the same exactly. It's just that this was on color, and when I tried to put it on the photocopy, it came out black and white. So this would be fine. Do you have that worksheet? The worksheet on. Okay, that worksheet will contain the diagram. Go ahead. Mountain. Oh yeah, definitely. If you draw a cross section, that's fine. No problem. As long as you are showing mountain, valley, and then sun hits up the slope, air rises during the day, low pressure on the slope, winds from the valley move up to the slope, giving rise to valley breeze. In the night, the other way around. If you draw only one diagram to show those two things too, it will still be okay, as long as one represents by day, the other one by night. And one diagram, like you have a mountain, two mountains, the valley, and you rotate the arrows to indicate how they operate during the day and how they operate during the night, it will still be fine. Otherwise, it's here. Your worksheet there will contain, so as long as you understand this, that's fine.
Does this effect on the breeze. Like this one, this is sunset. Yeah, this one. So that this side of the winds mountain has any impact on the breeze.
On the other side,
Yeah,
yes, it will. It will. On the other side, you might have the development of the winds because you remember when we're talking about mountain and valley breeze, you're looking at mountains, and a mountain is not just like one small one. We're looking at a big area of where the mountains are and where the valley is. Let's take, for example, the Makam Plain, the whole of that Makam Plain, and you see the mountains are on the side. So it's a very big area we're looking at. So on the diagram, it looks like it's smaller. Yes, it will have an impact, but what we are saying is that because the slope here, if say for example it is in the northern hemisphere, the southern slope will be more heated compared to the northern slope. Therefore, the heat will rise a lot more where the southern slope is, giving rise then to a low pressure area being created. And because the low pressure is on the southern slope, the air will tend to move from the valley to the slope here to take the place of the rising air. Meanwhile, on the other side, if the temperatures are hotter compared to the valley, then still the breeze will still continue to take place because usually during the day, the winds, if you are living in an area where you are a mountain person and a valley person, if you live in that area, you will find that during the day, the winds will always blow from the valley to the mountains. During the night, the winds will always blow from the mountains down to the valley. And that's because of this concept of the mountain and the valley breeze. We are concentrating on one side, saying where the sun is heating up more. It doesn't mean that on the other side it will not be the same impact. It will still have the same impact. As long as there's a valley, as long as there's a mountain, and as long as temperature is the main factor, then definitely that system will still apply.
Okay, and I would like you then to complete those diagrams for your homework. And hopefully, with the two examples that we have looked at on the land and sea breezes and the mountain and valley breeze, when we do give you the assignment now to work on the local winds, at least you would be able to do some explaining on the reasons for why those local winds that you have selected blow at that time of the year and blow from this region to the next region and etc. Perhaps another good example, if you'd like to look at also, will be that of the monsoon winds. The monsoon winds are examples of local winds. They are local because they are confined to a restrictive area within the Southeast Asian region. They do not blow right throughout the whole world. They are only for that region, and therefore they can also be classified as local winds. So perhaps if you'd like to look up another example of a local wind and see the reasons for why they blow at the different times of the year, you can also make reference to the monsoon winds. With that information, that also brings us to the end of our lesson. So class, if you can stand up now, please. To the pilot teachers, our keyword for lesson 122 is local winds. Good afternoon and thank you, students.